recording the workshop.
Do you prefer our mics off?
As long as you don't have background noise, it's all good.
My kids are gone. I'm in my lab. That's why this is my background.
Yes, it seems nice and quiet for you. Others maybe not so much. Anyway, yeah, if you have folks come in, go ahead and mute yourself. Otherwise, you can stay unmuted and ask questions and stuff. All right, well, here we are, everyone. Welcome to Cybersecurity with Python and the Microbit version 2.0. This is the workshop day 1. This is the first of 3 sessions of this workshop. So this is the Monday, August 22nd, and then we'll be reconvening at 3 p.m. Pacific on August 24th and again on August 26th. This is going to be recorded and posted on YouTube, and especially for those of you on YouTube, if you want to get to this slideshow, and I think most of you will want to get to this slideshow because it has many of the links that I'm following, and so you can go to those links yourself. If you're on a tablet or a phone, you can use the QR code, and then I will go ahead and paste the link into the chat. So there is the slideshow. Now, to make sure that you can all see the slideshow, Ari, what was the choice in the way upper right portion of the screen again?
Yes, if you want to exit full screen, you have the view button in the upper right corner. You can click there and exit full screen.
And then apparently and then you mentioned, I think, that you can also just hit the escape key.
Yes, if you are in full screen, you just can hit escape and that will get you out of the full screen mode.
And then the reason we want to do that is because we'll probably have you doing, at least for those of you with a single screen, you'll want to be able to switch between the window with this presentation and the python.microbit.org editor to paste in or modify code. Okay, so with you today, we were planning on having me, Andy Lindsay, Ari Alvarez, whom you just heard, and then Stephanie Lindsay. Jeff Martin is standing in for Stephanie Lindsay and hosting today. Thank you, Jeff. A little bit about myself. I'm an electronics engineer, and so my background when it comes to cybersecurity, my background and interest is mainly in what are called embedded devices, and those are basically devices like your Internet of Things devices, things that are inside machines like small robots or other electronic devices. And so that is where my main interest of cybersecurity is, and that is also the emphasis of this cybersecurity workshop that we're doing for these next 3 days. I included some links in here, like here's a link to a recent Cyberbot robot workshop. And so you can go to the 3 workshop sessions by simply clicking the 3 sessions and follow the link, or you can see the online workbooks and stuff like that. And then there's also an electronics with the microbit. So this is a microbit controlled robot. And then this is learning electronics with the microbit. And I have some similar links to that there. So those are things that you can take a look at. And you can even do the at your own pace version of this workshop with the recorded versions of the other workshops. A little bit about Parallax. We've been around since 1988 and producing educational products and materials since 1997. We've got about 20 employees, and we're mostly dartboard center of the state, just outside of Sacramento on your way to Lake Tahoe. Let's see here. So one of the main emphases of Parallax is the electronic brains that go inside either products or inventions. So each of the products up top here are products that have a microcontroller that has been programmed. You know, a program was created for that microcontroller by engineers, and that program is loaded into the microcontroller, and the microcontroller is the device that monitors the push buttons, that updates the display, that turns on the microwave emitters in the microwave, and so on and so forth. And so it's essentially the programmable brain that interacts with circuits in products. But microcontrollers are in many cases also the programmable brains that interact with mechatronic devices, custom subsystems on engineered devices, and of course also in student projects. Chip and Ken Gracie are, Chip started Parallax, and Ken, his brother, came on. Chip's our chief inventor, and he started Parallax. And his brother Ken came on, and actually he's now our CEO. And he, I apologize, there's some kind of really loud noise outside. Can you guys hear it?
I cannot hear you. No,
yeah, your audio is
I
clean.
cannot hear the noise.
Okay, good.
No
I'm
noise.
glad it's getting filtered out. I can hardly hear myself all of a sudden. Oh boy, it just stopped. Okay, so Ken is our CEO. He runs the business. Chip is our chief inventor, and really quite the prodigy as far as inventions go. Back in the mid-90s, he created a device called the Basic Stamp microcontroller, and this really turned both the hobby and electronics prototyping upside down, because it was the first device that was actually approachable by somebody who had not either undergone technical training or engineering training. It was programmed in BASIC, which at the time was the beginner's language of choice. Fast forward 20 some odd years, more than 30 years now. And here we are with the microbit, which is really, in a sense, kind of yet another step in the progression that Chip started with the Basic Stamp. And the microbit was created by the British Broadcasting Corporation, that's the BBC. So you'll often hear it referred to as the BBC microbit. And it's a really awesome little device. It has a built-in display, built-in push buttons, USB port for programming. It also has a built-in radio, and that's why we've adopted it for cybersecurity lessons, is because you can have a bunch of microbits living on a radio network, and that's a nice, safe, and easy way to emulate the kind of networks where things can come under cyber attacks. But it's also nice because there's no IT support or network support required to get these things to talk to each other on their own little network, because there's no overlap between the network the microbits live on and the Wi-Fi networks that your students might be on at the school. It also has a built-in speaker, an accelerometer for detecting tilt and being shaken, a compass, and then there are pads on the bottom for sensing and sensing electrical connections and sending electrical signals. It also has a built-in mic on front, which I forgot to mention earlier. And basically all these things in a single device make it really a lot of fun. And on the BBC microbit site, the Make It Code It site, there's a lot of fun projects. Like if you need an icebreaker for your students, have them try some of these. And in fact, why don't we do an icebreaker right now? So I am going to the Beating Heart. I'm going to paste you this link in a second. I first want to show you how to get there. Okay, so when we go to Beating Heart, you can see there's a nice little introductory video. And then what they have as a default here is block code for this application. This oh, and I'm sorry, I didn't mean to open Beating Heart. I meant to open Step Counter. Step Counter uses that accelerometer I mentioned earlier. So it's got the same stuff, and it's got a it's got a make code blocks program by default. But see how it says make code in this tab and then Python over here? If you click Python, then you'll see the Python code. And one step better, you can actually choose open in Python. And it will simply open it. It's also going to offer to use the beta editor. And we will use that. And I'll actually talk about, where the various controls that you're familiar with on the version 2 editor can now be found on the beta editor, but I'm going to skip that for right now. So it has this code. And now I'll go ahead and send you the link. And I want you guys to try that. And copy. Okay, bear with me while I get to my chat. Paste. Okay, so go ahead and follow the link. And again, what you're going to want to do is when you follow that link, scroll down and you'll see the make code. And then you'll want to click Python. So here I am scrolling down again, clicking the Python tab, and then clicking open in Python. And also, let's take a quick minute to make sure that your microbits are connected to your USB ports. So we want to have our microbit connected and ready to be programmed. Something like this. It may not show you anything, but as long as you've got a couple of lights on by the USB connector at the back, we'll know that you're connected. Okay, can I get some thumbs up as to if you've got your microbit connected? 1, 2, 3, 4, 5. Oh, here we go. Here's the avalanche. 6, 7, 8, 9. Excellent. Way to go, everybody. Okay. Now, if you feel like you need another minute or 30 seconds or whatever, please always feel free to unmute yourself and say, hold up, I'm trying to catch up with you. Also, please feel free to unmute yourself and shout out a question. You can also put them in the chat and either Jeff or Ari will, in some cases, answer you directly. In other cases, bring it to my attention when they want, when they think it's a question that the entire group also could benefit from hearing the answer to. All right, so now that you've got your hardware connected, just as we did in the homework, let's click connect. And I have 2 microbits connected, so it might look slightly different for you, but yours will probably just say BBC microbit, and just make sure to click to select it and then click connect. And then it should show a connected icon and should basically tell you that if you click it again, you will be disconnecting. Okay, once you're connected, we can go ahead and click the flash button to load the script into the microbit. And then once the script is loaded, I'm going to press and release the reset button to start at 0 again. So that's on the back right here of the microbit by the USB cable. Okay. And now it's showing me that I've taken 1 step. And each time I shake it, it'll increase the number of steps it's displaying. So this is an example of some of the things that a microbit can do, just, fun stuff with all its built-in sensor and display. How are we doing? Did you guys get that to go? Excellent. Got 1 thumb, 2, 3, 4. Oh, good. Okay. All right. So with that example of the make it code it stuff, I wanted to also, along these lines, make you aware of this YouTube video where I take basically a deep dive into the teacher resources available for the microbit. This is more this is mostly oriented towards the middle school level. And so if any of you middle school teachers out there are looking for computer science intros and other things of that nature, this is a really good link. It's a 2-hour video that looks at the related resources around this Make It Code It site where we just went to try that fun example. Okay. With that aside, today we are going to, there'll be a little bit more intros, and then I'll switch over to intros and overview. And then we're going to review some of the homework that we had, since it's going to be really important to be able to quickly do the things you did in the homework before this workshop started. So we'll be looking at saving, renaming, and opening a script. We'll also review the basics of coding that you tried out, those being communicate, remember, decide, and repeat. And then we'll go into some more computer science-y subjects today. So that's going to be comments, modules, strings, and dictionaries. Not actually in that order, I don't think. More on that later. If time permits, we'll do radio basics. Otherwise, we'll just insert that on Wednesday. Just depends on how far we make it. Okay. Next up, just a little bit of background behind where all this is going to fit. IoT, the Internet of Things. That is not really always everybody's first priority. I really think that, for cybersecurity, we're looking at our infrastructure, and we're looking at protecting networks of municipalities and businesses and stuff like that. So we're trying to keep hackers out of, our corporate and city resources. But there is another side to cybersecurity that involves the Internet of Things. And so I added a couple of articles here that you can take a look at about how the Internet of Things is a place where vulnerabilities are found, and they give hackers entry into more resources than you might think. And so in this slideshow, you can just click the picture, and then the link will appear below, and you can follow the link to read more about that. And so those are 2 IoT articles. Now there's also military/industry. Other things on networks are, for example, this is a news article that explains what the United States and Israel collaborated on in order to, they created a virus that basically damaged Iran's centrifuges that they were using to purify nuclear materials for the goal of creating nuclear weapons. And this was done back in 2010, and it was a really groundbreaking achievement. Now, the United States, I don't know if they've ever officially acknowledged it, but the media is saying that they've been in there. And this is an example of how machinery can be on a network with computers controlling it. And if a virus is inserted into said network, it can do a lot of damage. And this is another place where the microbit, especially when it's inside a small robot, can give students sort of a hands-on early example of how those kind of vulnerabilities work. And then this is a second article about a more recent virus that disabled Iran's weapons systems after there were some exchanges of fire. Basically, a drone got shot down and some other things. You can read about it again in the article. But so these are examples of where the microbit can fit in at a very low, shouldn't really say low level, at a very fundamental level to help students understand that, hey, there are things that aren't just computers and networks at workplaces and schools and so on that have vulnerabilities to cyber attacks. And so in general, this curriculum that I'm going to be introducing is not really an entire cybersecurity or an entire computer science curriculum, but it has a number of elements of both. And so in this slide, there's 3 different places you can click. The first one is this overall page. That'll take you to learn.parallax.com. Oh, pardon me. This actually takes you, I meant to back up one more step. So this outer page takes you to Cyber Students, which is just a shortcut to our cybersecurity material for students. And inside there, you will see a link to the Cyberbot tutorial series and the Cybersecurity tutorial series. The Cybersecurity tutorial series is actually material that we pulled out of, or rather copied from the Cyberbot tutorial series. So if you're just using a microbit, you can take your students through a number of computer science and cybersecurity lessons without needing a robot. Now the robot is pretty awesome. So there's a great deal of material here. Each one of these are essentially links to a chapter, and so that the robot adds another dimension, makes it more exciting. But the if I back up here, then there's the cybersecurity tutorial series, which has many of the same components. So the prerequisites are basically the same in the 2 of them. Looks like there's one thing that's not there. And then you'll see, if you look around, you'll see that, for example, there's some cybersecurity entries down in the Cyberbot robot section. And then those same cybersecurity entries can be found in the main lessons here. So you can click the outer, or you can go to the Cyberbot or cybersecurity straight from the slides. Additionally, if you go to learn.parallax.com, I want to emphasize that if we go to the homepage of learn.parallax.com, that this is where you can find student resources for an even wider variety of robotics, programming, and electronics lessons. And these are all freely available for you to see what the students would be doing in each thing. So you could look at the activity robot, for example, which its emphasis is multi-core. The SumoBot robot, obviously, they bump into each other, try to push each other out of the ring. For Arduino enthusiasts, we've got the BOE Shield bot, and quite a few more here. And then we also sort it by language and by type of hardware. So that's learn.parallax.com, where the specific material we're going to be going through lives. Now, the cybersecurity unit that we're going to be doing encompasses a number of computer science lessons that come before the cybersecurity lessons. So this is actually kind of a nice, it can cover a number of the standards alignment checklist items in a computer science class. And then it can be an additional, or like an add-on or a point of interest in a cybersecurity curriculum. Or it can simply be a cybersecurity oriented extension, again, added to, again, as part of a computer science curriculum. Okay, so would anybody like to ask questions or make any comments before I move into the homework review?
Hey, Andy, I do have a question.
Ah, yes.
When you were showing us the different types of bots, and you said that it had the programming language that goes with it, is that the only programming language that you could use with the bots?
Well, some of them have more than one programming language. So, for example, if we look at the robot, see, I guess that would be hardware. So if we look at the ActivityBot robot, so the ActivityBot robot is an example that can be programmed in C and in a block programming language called Blockly Prop. It's Blockly for the Parallax Propeller microcontroller. And so these are the two language options for this robot. Let's see. I think most of the other robots have a single programming option. For example, the Cyberbot is primarily a Python. You know, we built these tutorials around the Python programming language. There are other languages for the microbit. We focused on Python. I do know that there is a MakeCode block version in its early stages. And once you're using MakeCode, there's also JavaScript and let's see, JavaScript, Python, and I'm blanking on the other language. They have 3 languages that they support. But that would be, you know, a significant extra effort on behalf of the teacher since all of these examples are going to be using Python code, and the documentation in the textbook focuses on that Python example in terms of explanation, instructions, and etc. Okay, was that okay, Miranda? Did I get your question properly?
Yes, you did. Thank you.
Okay, thank you. All right, next up is the homework. So we did, better close some of these tabs. All right, so one of the things we did was oh, that's interesting. Okay, here we go. Okay, so one of the things we did was just basically went through and make sure that the microbit was up and running. And so this we all did, and for anybody who's watching this on YouTube later, you'll want to follow the link on that slide and go through these steps. And then that's just basically verifying that you can connect your microbit to a computer and load code into it. Then let's see here. We also are trying to do this to support it on 2 computers. For these cybersecurity lessons, not so much today, but on Wednesday, we'll be using 2 microbits. And those 2 microbits are either going to be connected to the same computer or to separate computers. So if you're connecting them to separate computers, there are links to the tests, which are much simpler. If you're connecting them to the same computer, then these are the tests and the links, which is just the microbit editor. And when you try to connect to a microbit, you get choices of 2 different microbits. And so, so this was a step-by-step set of lessons that, or, you know, set of instructions that everybody went through to make sure they could have both their microbits communicating with their computers, either 2 separate computers, which was here, or 2 computers at the same time, which started here and goes into the next slide. And then this is what it looks like when you're choosing your microbits before you hit connect. You have to have 2 editor tabs open, and then you can connect to a microbit. If anybody's having trouble today seeing messages in from the microbit, not on the LED display, but I'll be showing you some examples from the terminal that's built into the editor in a little while. And usually there's a battery consumption icon on your in the lower right of the screen, or sometimes upper right, depending on whether you have a Mac or a Windows or Chromebook machine. And there's you can change the power consumption settings to max it out, and sometimes that will help improve the display that you see when you're communicating with your microbit through a terminal. Okay, so one that I do want to go through and make sure that we've all got figured out here is saving your work. So there was a a set of instructions that we went through for that in the homework, but I want to do that all together as a group. So let's see here. I accidentally closed my python.microbit.org editor. So we all want to go to python.microbit.org/v/2. And for now, we'll skip that beta again. And we'll have a plain old hello world program. So to save this program, let's give it a name to remind us. And so this default program has hello world, and then it shows a heart in the display. And so a useful name might be hello world heart. And so hopefully that'll trigger everybody's memory when they're reopening that program. Now, to save it, first of all, we want to connect and make sure that it's working. Now, I have 2 microbits connected, so this is where you want to choose one of the 2 microbits. And so I'm choosing this upper one and clicking connect. And then once we're connected, we can flash that program and make sure it works the way we want it to. And so, so here it is. It's kind of hard to see the hello world, but there's the heart, and then it's doing hello world again. And so now we've tested this program, and we're happy that it works, and we want to save this in case we need to open it up later. So give it a name in the script name field, and then the steps for saving are using the load save button, and then make sure to click download project hex. We avoid download Python script in most cases. So download project hex.
Andy, can I ask you why you avoid saving them as Python?
Yes, I'll show you.
I mean, I understand the difference between the two, but
well, okay, so the first reason we don't want to do it is because when you click download Python script, what you're presented with is a warning saying, hey, that script can harm your computer. And so you have to manually tell it keep. And there may be some school networks where it might be more aggressive about filtering that. You might never see it. And so your students might have a difficulty because they're saying, I tried to save it, but it never saved. Or you might get a bunch of students coming to you saying, what's this message? We're studying cybersecurity. And so that's one thing. The other thing is going to come later. And what it is that a hex file can contain what are called modules. Modules are pre-written pieces of code that you can add to a project that do special things. For example, the Cyberbot robot that I mentioned earlier, that requires modules. There's a Cyberbot module that you have to add to your project. And if you save if you only save the Python script, you lose the module and you have to go through all the steps of adding the module to the project again. Whereas if you download the project hex, the module will travel with that hex file. So you'll only have to add the hex file once, and then you can just open a hex file that had the Cyberbot in it. And so then the next thing to do is you'll want to take a look and make sure you know where that showed up. So it's, for me, it's in my downloads. Let's see. There we go. So here it is here we are in the downloads, and this is the second time. This is the first time I downloaded the hex file. This was the Python download that I approved manually to save. And then this is the second time that I downloaded the hex file. And so those are the files in your download. So that's basically how to save. Now, let's change this program. Let's maybe say, hello, cybersecurity. And then we can maybe say image smile. And then let's flash that modified version and test it out, make sure we can see the hello cybersecurity message followed by the smile, which doesn't have any eyes. It's a little creepy, maybe. There's the smile. I can't remember the name of it. If we can get a smile with some eyes on that. So try that, make sure it works, and then give me a quick thumbs up once you've got it working. Thank you, thank you. Looking good, excellent. All right, so now we have a modified program. So we don't want to necessarily save it anymore as Hello World Heart. We might want to save it as Hello Cybersecurity Smile. So go ahead and give it a name, something like that. You know, whatever will jog your memory so that you could get back to this file and then go back to load save and then download Project Hex again. And this time, the name of the file it downloads, instead of Hello World, it downloaded Hello Cybersecurity. Now, if you want to open a file that you were previously working with, so I'd like everybody at this point to click at the bottom of their Chrome, click the Hello Cybersecurity that you just downloaded. There's a little upward facing caret right next to it to give you more options. And for me, since I'm on a Mac, it says Show in Finder. In Chrome, it might say Show in Files. In Windows, it might say something like Show in File Explorer or Show in Files. I'm not sure which, but find that option so that you can see. It's just a quick way to get to your downloads folder. Now, the other way you can do that is just simply open a file browser for your operating system and then, you know, look inside the downloads folder and ideally sort it by date modified, so that your most recent work or your most recent downloads have naturally trickled to the top. Okay, so let's get some thumbs up when everybody's there. Okay, you guys are doing great. Now, there's a shortcut to opening a file. You can use the load save button. I'll show you that in a sec, but you can also, all right, so we've got Cybersecurity Smile Hex right now in here, but you can also go back to say Hello World Heart. And in most operating systems, you can simply click, drag, and drop that from your downloads onto your python.microbit.org editor. Now, when I let go, you'll see it change from Hello Cybersecurity to Hello World. I'm going to let go now. And there we are. So that's that's a quick way to open a file, is simply drag it from whatever folder you're storing it in. And then drop it onto the editor. Now, the second way, in case that doesn't work for you, is to simply hit the load save button. And then their way of opening a file is this or browse for file link. And it drops you straight into downloads again. And you can then select, in this case, Cybersecurity Smile, since I already have Hello World open. And then And then we can hit open. And we're back to hello, cybersecurity. So I wanted to really focus on that for a few minutes, since it is a little bit different from the way you might be used to in something like Microsoft Word in terms of saving and opening and renaming a document. Okay, so how are we with that? Any questions? Okay, good, thumbs up. I'll take silence as assent and continue to the next topic. Unless somebody jumps in, unmutes themselves and says, hey, Andy.
Hey,
Or,
Andy.
yeah, oh, hell.
Yeah.
Hello.
When you talk about embedding modules, are you talking about when you're like adding libraries where you're doing an include or something, the equivalent of what we're doing?
Yeah, I'll jump ahead for a sec. So this is
It's okay,
coming
I
up.
just-
So this is the beta editor. And here
I see.
there's an object that we're calling adder.
Yeah.
And this adder object is in adding.py. And then basically the main code after adding the adder adding.py.
Yeah, it calls it as functions.
Yeah, it calls functions or methods within this class. And so we created two versions of the class, and then and then we call each one of them, and each one has its own personality. And I will get back to that later. But so two things about this. One is with the new beta editor, you can edit modules, those being the extra files that have pre-written code that does special things. And then by providing other people with those modules, they can have really simple code that they're using, and you're just providing something that makes the job a lot easier for them. And so that's I'm sorry, I forgot your question.
Well, the reason I was asking about the modules part for hex, because one of the reasons that I've always saved as Python was that I'm looking, I probably got 6 or 8 files I saved as hex. They won't open into any editor, and if I open them in they're like precompiled. So it was just interesting. I know that the hex files, if I go and save this as a hex file now, it will open, but I have other ones, from a couple of years back or whatever that
that is very interesting.
Can't
Let's
get back and see the code.
Yeah, that's pretty interesting. I'm wondering if maybe, since you were an early adopter, maybe the format of the hex file is old enough that you'd have to find a older version of the editor to open it.
It could very well be. That's okay. I mean, I can reprogram these, and I think that your comment is solid enough with, adding in these modules, that wanting those to be embedded and not have to go and find them makes absolutely perfect sense.
Yeah. Although I do see, it could be like if, for example, 10 years from now, the editor has evolved to the point where you can't open your hex files anymore. I can definitely see an argument there for just basically having backups in .py. So for day-to-day having the students work with files, if they're only doing it for a semester, I'd keep them on the hex file. But yeah, I think in your case, yeah, the .py for backups, that's a pretty solid approach. So yeah, thanks for mentioning that. That's a really good idea. Okay.
I have a quick question.
Yes.
Is there a way to save the code that's currently running on a microbit?
Not that I know of. If anybody, feels inclined to jump in, there's probably some really clever way to read it all out of the memory, but I have not run across it.
Everything that I have found has said that if you can see what's taking place on your microbit and you know enough about coding, it will be 10 times faster to rewrite it than it would to try to get in and be able to hack. It's in a special area. It doesn't even appear in any kind of browser, and it would be a compiled version. You would not see the code anyways.
Ah, okay.
Yeah, but that's an interesting topic. So if anybody runs across something before the end of the week, send me an email. I'll share it out with everybody else. Otherwise, yeah, I don't know of the way either. All right, so that was saving and reopening files. Now we'll just do a real quick run through on the coding basics before moving on. So this was also homework. We'll call this a homework review. So here is an example that's using all the little pieces that we did. The communicate, remember, calculate, decide, and repeat. And there's 3 faint dots at the bottom center of the presentation. You don't need to worry about this. I'm just telling you this for later because I'll paste this into the chat. But if you want to get to this code example later, there's 3 faint dots at the bottom that you can drag upward to see the script. So I'll go ahead and copy this out. And I'd like folks to check and make sure that there's indentation in the repeat and the decide, because if you copy and paste it into your editor and there isn't indentation, we'll need to address that. Chat.
I have indentation.
Oh, excellent. Okay. Let's see if we get indentation if I paste it into the chat. Okay, there we go. Okay, so I just pasted the script into the chat. And so shade that and copy it, and then go over to your python.microbit.org editor. And this is where we talked about earlier being out of full screen if you only have a single monitor. If anybody needs a refresher on getting out of full screen so they can paste into their python.microbit.org editor, just give us a yell. Otherwise, I'll assume everybody's got that okay. So basically shade everything that you've got in there, paste your code in, and then change the name to, I believe it's the basics. Yes.
Yes, and the indentation is there.
It's here on mine. I'm just my main thing is
I just try copy and paste, and it is here on mine too.
Ah, thank you, Ari. I've misunderstood. Yes, good. So if anybody does, so everybody please check under decide to make sure that your print statements are indented. And then under repeat to make sure that your print and sleep statement is indented. And then there's also later on, or at the very bottom, there's some indented stuff. So let's first run this and make sure that we can see what it's doing. So go ahead and flash the code, and nothing will happen on your microbits display for this one. It's just going to be blank. But we can use the reason for that is because instead of display.show or display.scroll, we're using a statement called print, and the print statement sends its output to the serial terminal. Now, some of you may not see this immediately, and if you don't see anything happening like this, see this send Control-D to reset button right here? This will restart your script. So I'm going to click send Control-D to reset now. It's infinitely counting on my computer. So if I want to restart the script, that's another thing you can do is press and release that send Control-D to reset. And then it goes through and it does its thing. And if you scroll up, if you point at it and scroll up, it'll stop automatically scrolling down, which is a really nice coding touch on the BBC folks, the way they set up this this terminal. All right, so the first thing it shows us is hello. Then it shows us a list of numbers. Then it says, hey, there's a variable and its value is 7. And then it says something about an inequality. and we'll go back and take a look at what it's saying. And then it starts counting. It counts from 1 to 9. And then it goes into an endless loop where it continues counting forever with longer pauses between each count. I'm guessing that's 1 second. All right, so is everybody able to verify that they got that on their screen? Oh, yeah, you guys are great. Okay. All right, so now
Well,
let's.
I think maybe I missed a step. So I loaded the code. How do you get it to run?
Oh, okay. So to see the code after hitting flash,
Right.
you want to go to the open serial button. It's the 4th one over. And if you don't see this immediately.
Yeah, it's scrolling now. Okay, there it goes.
Okay. And then if you want to restart it though, you can always hit the send Control D to reset and it'll restart it. Another way to restart it is right next to the USB cable where it goes into the microbit is a reset button that you can press and release. And that also restarts the program, the script, pardon me. Okay, so then close serial, and let's just talk briefly about this. Okay, so this, by the way, is a summary of the first chapter. So in the first chapter, this whole activity is communicate, then remember, calculate, decide, and then they're calling it count and repeat. But it's essentially repeat. And then count actually is sort of a function of calculate, which we did earlier with solve math problems. But that aside, those are the really basic programming tasks that folks do in a script. And so I just did this as a quick summary. During the previous session, we went through this together as a group and typed it all in. And actually, yeah, I need to remember to show you that. So we typed it all in, but just in the interest of time, Sleep 2000. If you see this and you don't know what it does, you can always hit help and go to documentation. And then in documentation, you can type in sleep. Okay, and then here is utime.sleep. And I'm going to go back. Here it is, microbit sleep. Okay, so it's worth mentioning that there are different modules. So this is the utime or microsecond time module, and it has different versions of sleep, but there's the microbit module, and the microbit module is the one that this script imports. And so we want to look for microbit.sleep. I'm freestyling a little bit here, so I kind of threw myself a little monkey wrench. So here is microbit sleep. And it explains that sleep is in milliseconds. And also it shows you microbit. If you said simply import microbit, then you would have to say microbit.sleep of 2000. But since we said from microbit import star, you no longer have to put microbit in front of sleep. So they're showing you microbit.sleep here, but because of the way that most of the examples import it, you just make a simple call to the module's function. You say sleep 2000, and it basically says, oh, 2000, that's the number of milliseconds, which is what you can look up here in microbit sleep and find out about the millisecond count, millisecond argument. Then we have print, hello. So that is the first thing you see in the terminal. After that, this is the remember part. So remember creates a variable A, sets it to 2, creates a variable B, sets it to 5, creates a variable F, sets it to 1.414, and a variable T, which we're going to call text. And although these names were kind of arbitrarily picked, F is kind of nice for a floating point number, and T is kind of nice for a text, or S for a string. And then this print actually prints all those guys next to each other. For calculate, we're just using plus, but there's also minus, divided by, multiply, and so on. And so this is calculating. And then when we saw the C equals, well, C equals A plus B. So we want to make sure that C is 7. So flash and open serial. So let's see so far if that's working out right. We've got hello. We got our list of numbers. We've got C equals 7. Then it says B is greater. Let's see what that's about. Okay, so it's basically, this is the decide lesson, or this is a, kind of an excerpt from the decide lesson. And we have, if A is greater than B, type A is greater. Else elif, that's their version of else if in Python. B is greater than A, then print B is greater, and then our catch-all, if none of the other things are true, well, in this case, that must mean the two values are equal. And that's why it said B is greater, is because we look at A and B. A is 2, B is 5, so B is definitely greater than A. And so that's why it printed B is greater. And you could change these numbers to get the other outcomes that are part of this compound statement. Under repeat, oh, yeah. Anybody want to stop and tell me to not forget to talk about something that's related to this statement here? Starts with an I, ends with an N. Indentation. It's a big deal in Python. So basically, if I had not indented this and I try to run it, I'll see an error message printing on my microbit. And if you go to open serial, it'll say, hey, you made a mistake on line 21. That's invalid syntax. And sure enough, here we are on line 21. I was not indented. So in order to have something, some statements get executed, if this condition is true, it needs to be below and indented. And then the next thing that's not below and indented is either when we're done here or if that condition is not true. So for example, I could copy and paste this. And now I have another indented. And it has to be, I can't do that either. That's not right. So there's the correct indentation. And so then we could say, really, it's greater. Oh, don't want to use the apostrophe here. It is greater, exclamation point. And then we can flash that. And since B is greater than A, it did both of those things because both of those things were below and indented from that condition. After that, yes.
With regards to the apostrophe, if instead of using single quotes, you use double quotes.
Very nice.
Fine.
So, so what Alan was just mentioning here is that if I want to display an apostrophe, and we cover this in the strings chapter, if I want to display an apostrophe like that, if I'm using a single quote here, as long as I have the string enclosed in double quotes, I'm okay. And there's a lot of other different ways to have strings. For example, you can even use triple quotes for strings, although we more commonly use that for commenting out a section of code. Because you can put triple quotes around something. And you'll see it change color all the way to the bottom. Then see, now it won't do the decide block of code because I have changed the decide block of code into what's called a multi-line string. And that's getting ahead of myself a bit though. Thank you, Alan. Yes. Let's see. So then repeat. The simplest way to do that in Python is to use a for loop, and you can give it a variable for counting and then say in range and do the starting value and 1 greater than the ending value. The reason for that is a lot of indexing stuff. It's better to skip the last value. Like if you're counting from 0 as opposed to counting from 1. And so this is going to actually count to 9. Now, another way of counting and repeating is saying something like while true. You can also do while and put a condition in here, like while n is less than A or something like that, or while n is less than B or n is less than C. And then, or n is less than 20. And those would work. And while true will just always keep repeating. And so this would be our endless loop main app, like the main loop in the application if it's going over and over again. And notice we have 3 lines that are all indented. The first one's printing n equals, and then the value of n, then it adds 1 to n, and then it sleeps for 1,000 milliseconds or a second. And so now we have reviewed the entire application of the chapter that you guys went through before the start of this workshop. And with that, I think it's time to take a quick break, stretch our legs, go and get a glass of water or whatever. So let's go ahead and reconvene at 4:10. Yeah, right now I'm seeing it's 4:04 on my watch. So 5:04 Mountain, 6:04 Central, and 7:04 Eastern. So come on back in about 6 minutes and we'll resume. And anybody who wants to hang out and ask questions or make comments, feel free to do so. But mainly anything off topic for now.
Yeah, we have a couple of questions. I'm not sure if you want to answer once we restart. Stephanie was asking if there's a way to clear the editor area, like we always select and delete. And she was asking if there's a way to just clear that.
Okay, so was she asking about clearing the editor or clearing the terminal?
The editor.
The editor, okay. So are we thinking just like, first of all, I better say
other
this.
than selecting and deleting, which we usually do?
I'm unfamiliar with like a Control N or anything like that. It's web-based, so Control N opens up a new browser, but a Control A to just select and then delete. And then the only thing I remind people is make sure you're changing the name so you're not saving on top of something.
Okay. Yeah, there is a way to clear this, but I don't remember it. It's a pretty interesting string. Okay, Python clear terminal. There's some kind of string. Oh, maybe just clear. Okay, that wasn't the solution that I had. Here it is. This was the solution I remember finding. Let's see if that still works.
Talking about just adding it within your code.
Well, it doesn't clear the script, which is what I think she was asking about. But for example, if I added this print statement right here. See if it counts to 9 and then clears. There we go. Kind of wish it had positioned the cursor up top.
Yeah.
Better get that out of my code though. Yeah, so the other way they're saying is to import OS. Yeah, I'm not sure if that'll work. I'd have to test it. Any other questions, Ari?
Yes, Robert asking if you have something that is sending information back to serial, if you disconnect or close the serial terminal, can you reconnect?
Okay. Trying to figure out what he means. When you close serial, does the script still run in the background?
Yes.
Ah, yeah. So, I think it does, but when you open serial, it restarts the script. So, let's test that, make sure I'm still telling that. I believe that's correct.
That's correct.
Okay. So if we flash it, so the script is starting, it's running, but I closed it. Now, if I were to reopen it and it had counted to say more than 6 or 7, then we'd know, but instead it looks like it starts right over from the beginning again. But it really is running in the background. So for example, if we added display.show here, then we'd end up seeing that it was still running. So I'll flash this. And then, okay, so it'll restart when I open the serial. But when I close the serial, you can see in the monitor that, well, that wasn't the best of examples because I didn't close it in time. Let me, okay, so now I'll close the serial and we can see that it's 13, 14, 15, and so on. So it's still running even though serial is closed. But as soon as I open serial again, there we go. Okay. So that was how to delete everything that's in your script and whether or not the script continued to run. Yeah, thank you. The display did stop at 9 the first time. Okay, now did I say 10 past for the break? Okay. All right, let's get started again, everyone. First off, there were a couple of questions in the chat, so we'll go ahead and do those. The first one, let's see, the basics modified. I'm going to save this so I don't lose it. So that's load save and then download project hex. the first question was, all right, I want to delete all the code that's in there and start with something new. Usually the shortcut in Windows, it's Control A. In Mac, it's Command A. So that's to select all the code, and then you can hit delete. Now, if you want to get your code back, you can either do Control Z in Windows or Command Z. And then I don't know, anybody using a Chromebook, please tell me if there's a different sequence or if it's Control A, Control A, delete, just like it is with, okay, I'm seeing Jeff nodding his head, which means
Yes,
it must be right.
it's Control A.
Jeff is our resident Chromebook expert. Okay. It's kind of an understatement, really, Jeff. Our resident Chromebook super user. Okay. So yeah, to delete, Command A in the Mac, Control A in the in Windows, Control A in Chromebook, and then just hit the delete key or the backspace key. If you want to undo what you did, Command Z or Control Z will take you back. The other question was, does the script still run if I've closed the serial terminal? So we open the serial terminal and we can see the script running. And what I did was I modified it so that it's displaying on the both on the terminal and on the LED display. And so to answer this question, we're coming up on 20. I'll close it at 20, close serial. And we can see that 21, 22, 23, 24. So it is still running, but when you click open serial to reopen it, it restarts the entire script. So just keep that in mind. All right. So that was part one of our coding clinic. And so let's see, python.microbit.org documentation, or actually what I should do is I should just paste in this since it's slightly modified. All I did was I added some display.show statements below each print statement in the counting part. For that, you can do Control A or Command A to select all again, and then you can do Control C or Command C to copy. It's equivalent to right-clicking and selecting copy. And then we'll go ahead and paste into the chat. So here is the modified, the basics script. This MicroPython documentation, this is a link to the documentation page. However, I recommend simply clicking help and selecting documentation, and it takes you to the same page. And this page starts, with a nice Python tutorial, and it takes you through a lot of the basics. And then it also has an API reference. So for example, when we were using the accelerometer to shake it and get a step counter, there's information about the accelerometer methods here, in case you wanted to look one of those up. So that is how to get to documentation. And now we're going to start building towards cybersecurity lessons. Since there's a lot of computer science and cybersecurity, since there's a lot of concepts being piled on top of one another, one of the things I did while writing these, the ones that I wrote, was to create a few common threads. And the first common thread is this countdown application that I'm going to have you do. So this is part of the Computer Microbit Talk chapter, and it's the last activity, input and print applications for the microbit. So I'll take you there and just show you first what's going on. Okay, so here we are in Computer Microbit Talk. And so we've already experimented with the terminal, but as the students are going through the tutorial, it's very step-by-step. So they get to try the terminal. They get to try out REPL. And I forgot to remind myself what REPL stands for. Read, evaluate, print, loop. So that's what REPL stands for. And it probably says so right in here. I just am not fast enough to locate that. So this is a thing, though, where in REPL, you can go into your terminal and interactively enter statements. So here is REPL with a print statement, print hello terminal. And then right below that, it shows you hello terminal. It's a nice little feature of the serial terminal. And so that's part of Computer Microbit. And then here's a multi-line statement for REPL to execute, where we have it count to 5. Then we go through and learn about printing to the terminal, and then sending messages from you, typing them in to the microbit. And then this all gets put together into a countdown timer, which is an application. For any of you who have to do stretching routines or warm-up routines, you might set your watch to count down, or if you're heating your oatmeal or coffee in the morning, or tea. And of course, on your oven, there's a countdown timer. So it's an application example. It's the simplest one I could think of. And so let's see, let me paste that in for you guys to try. Actually, before I paste it in, sorry, going to do one more thing. So we'll do countdown timer. So Command A, Command V, and that's Control AV if you're in Windows. And then we'll call this countdown _ timer. Okay, so what it's going to do is we'll flash it and then open the terminal, and it'll tell you to enter the number of seconds to count down. So in the interest of time, we'll do it for 5 seconds. And then there's a message after countdown. And so we'll start with liftoff. 5, 4, 3, 2, 1, 0, liftoff. All right, now I will paste that in so you guys can try it. Okay, check the chat now. So there is your next application. And we want to make sure that this one's working well. If you type and it doesn't show you any characters, you can try clicking the terminal. So again, you're going to flash the program, then click Open Serial, and then hopefully just at that point, you can type in your reps and your message. Okay, everybody got that going? No? Okay, I see 1, 2. Okay, good. Now we're starting to come in. All right, so this particular application, since it's a real thing that you can do, it's going to be repeated in radio basics. So we'll have the countdown stuff entered in one computer, zap it to the microbit over the radio, have the other microbit display the countdown, and then you're on a network. And so now you have an application that needs to be protected, and then we'll go through encryption to protect the application as it transfers its data. And then well, yeah, we'll go through encryption and then we'll go through how to prevent a couple of different cyber attacks. Again, just repeating this application since it's familiar. A lot of times I like to go for wow value, but I feel like, you know, since there's so many layers on this, to expand a familiar application instead is probably a better way to go. And especially since the microbit already has 101 different, you know, fun and exciting applications to do, the students can then go shopping and pick, you know, possibly another application that they want to protect. Next up is functions. So a function is just a piece of code that's reusable. And the way it works, and so here's another one where all the code, these 3 code examples are down in the comments. And so we'll try basic function first. Okay, so there is basic function. Control A, Control V. Whoops. Okay, I apparently pasted you guys in the wrong thing. Sorry about that. Let me try again. Copy. I probably used Control instead of Command. Yeah, now I got the right one. And here you go. Sorry about that. Okay, so basic function. So if we flash this, we see hello from main, hello from function, and then hello from main again. And the reason for that is because to create a function, you say def, and then at a minimum, the function's name and some opening and closing parentheses. And then also at a minimum, you need to have at least one statement inside the function. And again, like with counting and deciding, you need to have the code of the function below and indented from it. Now, when the MicroPython runtime goes through and sees this, it just makes a note of it, but it doesn't run that right away. It just says, okay, well, there's a function. Then when it reaches line 7, it says, okay, I have now a statement that I need to execute. Print hello from main. So it prints that. Then on when it reaches line 9, it says, oh, function. I need to go and find function and execute its code. So it jumps up here to function and it executes the code. And then it comes back. Then it moves on from there. And then it'll say, and then this is just another print statement. So that's why we see hello from main first, then hello from function, because it jumped up here, did it, came back, and then hello from main again. Hello from main, hello from function, hello from main again. Now, there are some different, in the interest of time, I'm going to skip over or skip to the most complicated one. That is function global versus local. No, sorry. Gotta stick with step by step here. Okay, so we're going to do functions next. And so this is more than one function, and there's a slight tweak on it that I want to make sure everybody's aware of. Okay, it should be in your chat. Yeah, this is functions, Flash, and open serial. Okay, so there are two functions here. One is called increment, and it just adds 1 to a value it receives. So the difference here is that now there's a variable or a parameter inside here that receives an argument that gets passed to it. Jeff, you can feel free to unmute yourself if I'm messing with the nomenclature here. I think I did that right, but just in case. So here is the function call. It's actually embedded inside a print statement, which is a pretty cool thing you can do. So increment 5 right here. And what it does is this 5 argument goes into the variable, the parameter in the function definition. And so value receives 5. And then value equals value plus 1 changes the value of the value variable to 6. And then it returns that number. Now at that point, this function call, I think the easiest way to think about it is this function call becomes that result. So what this print statement really becomes at that point is, remember, increment adds 1 to 5, so it becomes 6. So then print says it displays that text, and then it displays the value 6. Now with add, it's the same kind of thing, except for you have more than one parameter here in the add function. So you need to pass it the same number of arguments. So we're passing 5 to value 1 and 6 to value 2. And then the add function adds those together and returns the result of 11, which gets plopped right there. And so then print add 5 and 6, you get a result of 11. Flash, open serial. And there we have our result of 11. And when we incremented 5, we got 6.
And that's all just because you were able to create the definition of increment and add, correct?
That's right, because we made our custom definitions of increment and add. So for example, you know, I could do yet another one. Whoopsie, I'm using Windows controls when I'm not supposed to. And okay, so let's try Command C, Command V twice. So you could have a you know, sum 3, and then you could have value 3. And so yes, it's because we defined the behavior of that function, and underneath in your microbit, that's what the microbit architects did to define the sleep function and define the print function. And so we are now defining our own custom functions.
Right. And then plus is a native thing.
Yes.
To Python.
Yes, plus is an
That makes
operator.
sense. Right.
Yeah, and then we also have minus, divide by, multiply. I think this is modulus, which is basically, given a division problem, what's the remainder of the division result if it's an integer division. Yeah, I don't want to dive into that right now. It is coming up though, so so we will look at that later, and I'll call it out when we get there. Let's see here. And so, yeah, in this slide, it's just showing what happened with each one. And so the last one, I think I'll just talk about. Notice up here, it's declaring a variable named K. It's making K 10. But then we have increment. Increment is modified, and it's setting K to 3. And it's printing the value of K before doing its regular job of incrementing value by 1. So the interesting thing is when you print K here, you get the result 3. It'll show you 3. But that only happens inside here because of something called scope. And scope is essentially the scope where a variable is allowed to exist. And so K is declared inside this function. And so K only exists as 3 inside this function. And it exists separately from this K of 10, which is up here. So when we call increment of 5, it jumps up here, says, oh, K is 3. I'll print K. Great. But when it comes back with value, 6, that K disappears. So as soon as we get to return and it jumps back here, this K is gone. But this K is global. This was declared at the, first, and it was declared outside of any function or loop. It's not indented underneath anybody. And so this K, when it says print K down here, this is where we get 10 for K. So this was inside the function where it was 3. And then this is outside of the function where we're using the global version of K. So be careful about that because yeah, K can exist in 2 different places, and that's a computer science lesson about variable scope. And incidentally, this is discussed in the beginning tutorials. So when we, I'm basically still summarizing the stuff that's on learn.parallax.com since there's a lot of material and we need to squeeze it into a short amount of time. Okay, so now let's take a look at the, questions before we move on. Okay, well, as always, feel free to chime in if something comes to mind. All right, so let's talk about objects. A class definition is basically a container that you can say, once you say class adder, then your code can say, I'm going to declare an adder. And that adder will have these functions inside, and actually also it'll store this data. So a class can store data and can also execute functions. And the thing about an object is that you can also give it a personality by this magic _init. So self is just basically a placeholder where the object, well, it's essentially a required placeholder so that the object knows that it is itself. So we don't actually pass it that anything. It uses that to say, oh, I'm storing the fact that I'm the A instance of the object or the B instance of the object. So that's what's inside self. But the other things when you create an object are you can call it an A object. So this A equals this statement that creates the object. So this is a class adder. And when you say A adder of A in quotes, button A, and then the number 2, but A in quotes gets here in this custom object ID. So this is created by the coder, not self is fundamental to the creation of an object, but object ID is just something that I decided to put in there for the example. Button is another thing, and the step size is another thing. And so what this is doing is, I guess I should back up. Well, I'd better finish the explanation. Sorry about the poor presentation here. So we can create a adder instance named A and another one named B. And then inside this function here, inside adder called increment, and then we have to reference back to self, which is going to be A when we created this one, or B when we created that one. And basically button A is a way to, no, I'm sorry, this explanation isn't going to work because I got ahead of myself. Let's back up a little bit and run the increment function example first, and I'll explain what the problem is and hopefully do this in a way so that it doesn't leave you confused about objects if you've never done objects before. Okay, so I'll paste this into chat. Oh boy, oh, there it is. Am I still presenting?
Yes.
Yes.
Okay, thank you. For some reason, my control ribbon moved to a different spot. I was afraid that that might have meant. Okay, so let's run this program and talk about, or this script and talk about it. It's the increment function script. So we'll go ahead and flash this. And for this one, you'll want to go to Open Serial. And then you'll want to press and release the A and B buttons. So here I'm pressing the A button. And every time I press and release it, it increments a variable by 2. And then when I press and release the B button, every time I do that, it increments a variable by 3. We can go back to the A button and it keeps incrementing by 2, and the B button and it keeps incrementing by 3. So go ahead and verify that that works, and then we'll talk about this briefly. Okay. Did everybody get that to work? Excellent. Okay, looking good. All right. So that was pretty simple. We don't really need an object for this, but imagine if you had a whole keyboard. So maybe we're talking 26 keys, or even a 10 key, or, you know, I mean, I don't know how many keys are on a standard keyboard, but we've got 26, you know, alpha characters plus the numerics plus the functions and the shift keys and all that. So that's a lot of different values. So here with just 2 buttons, yeah, we can say if button A dot was pressed. That's the way to find out if the button got pressed since the last time it checked. And it can jump here and say, okay, value A, which is declared up here to be 0, value A and value B are declared to be 0. Then we can say if it was pressed, then call the increment function, and it'll display that it's the button A you pressed. It's passing value A, and value A is or, you know, which becomes value up here, and then it'll add step to the value. It'll print that value and it'll return the value so that we can keep track of it under value A as a variable, so that the next time you press the button, it adds 2 more to it, and so on and so forth. And then basically that's if you've pressed button A. But if you've pressed button B, then it does the same thing with the value B variable, except for this time we're incrementing by 3 instead of 2. And that all happens up here in the function. Okay, and this is well and good. It's just that for a lot of programming tasks where things aren't this simple, they get a lot more complicated. And so that's where objects come into play. So, oops. Okay, so now I'll show you the same functionality, but just using an object instead, a Python object. So this is the adder object script. Okay, so go ahead and try that out. So this is the object version of that script. Huh. Gave you guys the wrong code. Sorry.
If you paste it onto that slide, all of us that are live with you will see the updated code.
Yeah, let's see here. Need to get back to the slide. Okay, so first of all, adder object. Oh boy. Okay. I'm going to I think probably what I'm doing is I'm looking into the zip file that I let's see here. Need to get to Finder. You know what? I'd better let this example crash and burn because it's not of crucial importance. I'll just talk through it. Basically, this adder object, as I mentioned earlier, it's a way to create a whole bunch of buttons. So imagine if you had 26 buttons, wouldn't it be a lot easier to just create an automated response to each button? And so that's what this is. A is an object, and it's an instance of this adder class. And we pass it the object ID, button A, and then a step count. And then it essentially, using this self keyword, is given a personality of, it does something when you press button A, and it adds 2 to that. Likewise with B, it does something when you press button B, that's the button, and it adds by 3. And then so essentially, when you call adder.increment, it's going to go and check and see if it's A or B. And if it's A, it's going to, respond to button A and increment by 2. If you press button B, it'll increment B by 3. And so objects are a way to create something that you can configure. It stores that configuration and data, and then it knows which instance it is using this self variable, and then it does stuff. You can say adder.increment a.increment to see if the button was pressed and if a value got added, and you can do b.increment to see if the button was pressed and its value got added. And so this is the object way of doing this same thing. And the reason that this is advantageous, even though it looks longer here, is because of the fact that you can essentially assign this functionality at the beginning. And then anytime you call its function, it already knows, hey, I'm only going to respond if you press button B. And if you do press button B, I'm going to add 3. And so that is the way objects are done. And it's longer here, but it's shorter here because that whole object, the adder class, in here got tucked away into a module. And so adder lives in a module. It's added to the hex file. And so all you have to do is essentially follow the rules that are added to documentation somewhere that explain, hey, when you're using this adder class, you know, when you're creating it, you give it a name like A in quotes or B in quotes, you configure which button it responds to, and you configure how much it adds to each thing. And then you can go through this while true again and just increment if the button was pressed. See if self.button was pressed. Then, so it just keeps on cycling through there, and it checks for A. If the button was pressed, it adds something and displays it. And so this is the process that you go through to essentially make an object. So like when it said display.scroll, that's a display is a class, and display.scroll, that's a function inside the class. And so this is considered to be a method, or when it's inside a class, it's called a method. So when you see something dot something, and that dot something has like a function argument next to it, you know that is object dot, that's an object, and you're calling a method within it. So going back to here.
And they have the code in the chat. Other object is in the chat.
Oh, thank you.
If they want to run it.
That is great. And then I don't want to run this because I don't think I have a link for sharing the hex. And I can tell that I'm running out of time here. So I want to jump, you know, to a few more informational items before we wrap up the day. So here is some of the nomenclature that we just went over. So if it leads with a hashtag, it's a comment. This is a module that we're importing. So from microbit import star, that means import all the functions and methods and data from the microbit module. While true, well, that's just, you know, that's the earlier stuff. Then display.scroll, that's an object, that's a method call within an object. Now sleep, since there's no something dot something, it's just sleep 2000. That's a function call, again, within the microbit module. And image.heart, well, that's an argument that it was passed, but it also image.heart is a property within the object. So that's inside the object where you can't necessarily get to it, but it's hard coded. The code to display a heart is the information for that is in there as object.property. So don't worry too much about this. This is this object stuff is basically something that it does not have a tutorial yet. It needs a tutorial, and I apologize that this part of the workshop didn't go so well. I'll try to somehow make that better before the end of the workshop, but I don't want to dwell on it because it's really not required for what we're doing with cybersecurity. Only through functions is. Now, something that is going to be important for cybersecurity is lists and tuples. Okay, so a tuple is simply something that gets enclosed in parentheses. So it's essentially if you have well, let's just try out this code here. Okay, so there is the code in the chat. And when we run it, I just so let's take a look at this. So a tuple is basically a list that you cannot edit. So a tuple ends up in between parentheses. And this tuple, the 0th element is 3. First element is 1.414. Second is high. Third is 6. Fourth is 7. And so if you say tup, and then in square brackets, an index of 2, it goes 0, 1, 2, and says, ah, I need to give you the text high. Now, you can have a list that's the same items, but a list can have items changed. So we can change list of 2 to by. So, inside in the main script, it says list of 2 equals, and then by in parentheses. And then that's why we see by right there. So, oopsie, close serial. So here's the list. And we print the list. And then we print change list of 2 to by. Well, there's that. So we're actually changing what used to be the string high into the string by, and then reprinting it. And so that's why we can see that we start with the list that says high and then change it to by. So this is going to be important for the cybersecurity stuff. It's scaffolded on this as one of the concepts. Are we okay with that? Excellent. Okay, next up, trying to sprint here to get through lots of material before I got a little bit behind slowing down on that. Here is a fun application. Okay, so I'm going to give you this web page, and what I want you to do is just scroll all the way to the bottom and copy and paste this script into your microbit. And it's going to play music, so be prepared. Whoops. So this is an application of lists. And this is what it sounds like for anybody who's not playing it. So this is a list of notes.
Your microphone is doing an excellent job of noise canceling. We couldn't hear it at all unless you were talking at the same time.
No way, really. Well, hopefully you can all hear it from your microbit. Give me a thumbs up once you got that run. I can hear one. Good job, Alan. Okay, Carol, thank you. Kevin, Tracy. Thank you. So a list is another thing where you've got a lot of data, and it's basically a nicety that makes it a lot easier than creating a whole bunch of individual variables. It's just a convenient way to store stuff, and then your script can go through and access different elements of the list. We're going to skip this. This is another thing where you basically shake the microbit and it randomly picks something for you to do and displays it. Another nice application of lists. Dictionaries. Dictionaries are very important in computer science. They'll often come under the name JSON file if you're doing JavaScript programming. And dictionaries are important because it allows you to send information from one device to another, and that information has a key and a value. And so the key is something like name or score. And the value might be something like, well, Sir Lancelot could be the name. We're in Python, so we're going to choose something Python-esque, like Monty Python-esque, like Sir Lancelot. And then just for a score, the value can be 1,000. And so that's a list. And a list is contained in between curly braces. I'm sorry, it's a dictionary. Strike that about list. So this dictionary has two different key value pairs. Name, Sir Lancelot, is the first key value, score, and 1,000 is the second key value. That whole thing, because it's enclosed in curly braces, becomes a Python dictionary. And then you can give that dictionary a name like info. Then to find out the score, for example, you can simply say, some variable, in this case, number, equals info of, and then score in single quotes. And that'll go find score and give you back 1,000. You can also change the value within the dictionary, and that would just be the reverse, where instead of variable equals info.score, you can say info.score equals new, or info of score equals new value. So that's pretty simple, and there is a whole chapter on it, but I'm going to not do a bunch of examples from it because, again, I'm running out of time. So are there questions before we look at the next thing real quick? Okie dokie. Let's see here. So this is the dictionaries activity where we go through and try it out and see those things that I just mentioned. Exception handling is another thing that comes into play because if you've ever had a web page freeze on you, it was probably because it received some information it wasn't expecting and got stuck. But furthermore, it was because it did not have an exception handler in place to handle whatever it got stuck on, and so it stayed stuck. And so in terms of cyber attacks, another thing you can do with a microbit is give it some bad data, and it'll just cause its program to stop right there and not continue working. And so the example in the exception handling chapter starts off with a simple division problem. Well, if you run this and you give it a denominator of 0 instead of 5, it's going to give you an exception. It's going to basically stop, and it won't give you the answer. It'll instead tell you an exception occurred. And so this is exception handling, and you essentially take your script that worked, except for when you made denominator 0, and you put parts of it in the various parts of an exception handler, which are try. So this is the stuff that might have a problem. Specifically, that denominator might be a bad value. And as a developer, you can say, oh, well, let's print the exception and see what went wrong if D was 0, or maybe if D was a string of text, because the microbit would choke on that too. And students learn about the various exceptions. Now, else is essentially the code you want to run if this code that we tried worked. So if there was no exception, then instead of giving you exception information, it just does what you expect it to, which is to say, oh, well, here's the result of the division problem. And then the finally is just, if there's some extra statements that you want to execute no matter what. The idea here, though, is that this code doesn't stop or get hung up if you say D equals 0 or D equals some string of text inside quotes. it will instead tell you what went wrong. And then the chapter at the very end, it challenges the students to make sure that that except block, the except code right here, gives the user some kind of helpful prompt so that they can go and enter a value that is, that actually works, like 5, as opposed to 0 or the character string hello. I know we're out of time. Let me see what we've got left. I think we did strings. Yeah, so the one thing I didn't tell you about is strings. The thing about strings. Okay, can you all stay for 5 more minutes? Oh, thank you. Okay. So strings are strings, as you've seen before, they're just those things in between double or single quotes. Or at least that's the way they might seem. But strings are, in Python's estimation, objects, and they have their own methods. So, but I'm getting ahead of myself. The first thing was, and this is something that Alan mentioned earlier, that you can have strings in single quotes. You can have strings in double quotes. But the important thing here is if you put a string in a double quote, you can even have a single quote, like an apostrophe, inside those double quotes. You can you can create a multi-line string with either 3 apostrophes or 3 double quotes. And then you can even make it a single line string with backslashes. So there's lots of things built into Python that you can do with strings. You can even do \t for a tab, \apostrophe to insert an apostrophe. And so this is where the students are. And then there's the ASCII table, which talks about the numeric value of, say, the letter A, which is 41 in hexadecimal or 65 in decimal. And so moving on, the next thing we do is we talk about, hey, there's a string, and a string can contain numeric information, but it's not the same as an actual variable that was created and assigned equal to an integer. However, there are functions, like this one will tell you an ASCII character. This one will give you the letter that corresponds to an ASCII character. So if you put ORD and then A in quotes, you'll get 65. If you put CHR of 65, you'll get capital A. Length will tell you how long a string is. And then if you have like a number, you can say STR of that number, and it spits out the string with the digits in it. So like here's S equals 1, 2, 3. That's a string. That's not a number. But N equals int of S will take that 1, 2, 3 and say, oh, let's give you the integer value of that. And so then what I'll have you do, one of the things I'll have you do in the homework is to try, and it'll be optional, but you can try using these different things, like try adding this to a script, and then try adding these things to a script. So there's more. You can find something inside a string. You could, if you use string.find, it'll give you the address. So we're looking for sequence. So it'll actually count the number of characters over and tell you where that S in sequence is as a number. String.replace. So you can go and find, for example, it, and replace it with a string. So it'll jump and find the first instance of it and say, this is a string. And then in this case, it'll show you a string is a sequence of characters. You can actually convert a string into a list. which like the notes that we were playing earlier, except for it's just a list of comma separated characters. You can also change them to lower and uppercase. So these are built-in methods of your string object. All right, so that concludes today's whirlwind tour of the computer science part of our cybersecurity material. And for homework, what I really want you to do is I want you to, number one, just go to the bidirectional texts page and read it. You'll also want to connect both your microbit modules, because this is going to be something where you're doing a chat application. So going back, here is an example of the chat application that you'll be testing out in your homework. So you click one terminal and type hi, hit enter, it appears in the other terminal. And then you click the other terminal, type I'm a Cyberbot. Well, this was a Cyberbot example, but you don't have to say Cyberbot, you can just say microbit. And so the idea is you can click one terminal, type something in, and when you hit enter, it should travel to your other radio connected microbit and display there too. So this is a second application that needs to be protected in the cybersecurity portion. And this is part of Radio Basics. It's actually the last one. And so I'm going to have you, oopsie, I didn't mean to do that. I closed my, just a sec. I'm trying to get the slides back up. Okay, here we go. Thanks for staying a little bit late, folks. We're almost done here.
You're buying the first round, right?
I'm sorry?
You're buying the first round.
For anyone in the area, for anyone close enough to join me at the bar, absolutely.
Be careful.
Yeah, I can tell Alan's going to take a Southwest flight north, right?
Yep.
All right. So what I want you to do again is read bidirectional texts. It's a real short page. And it's just to see the script, just read and see how the students are instructed to do it. Now, the reason I'm not having you follow the instructions with this page is because it's skipping some of the earlier activities. So what I did in the slides, and I'll probably copy this.
Do you want to share the screen?
Oh, darn it. Thank you. Let's see. I did not realize I went out of screen share too.
George Carlin had a great script, a great act about this.
Okay. Email me a link to that. I want to see it. I could use some humor after after this little end of workshop session here. So can you see now? So bidirectional text, I just want you to read the page because we're not going to be doing because the page, the bidirectional text page assumes that you've tried a number of things, and so it's skipping some steps. So what I did instead is just look at the bidirectional text page, and then after that, here is your step-by-step thing to make sure that you can make the chat application between microbits work. So basically, here's the video, here's the link to the page that the students use, and then here are your instructions, very carefully worded. There's also the optional thing I talked about with the strings is if you'd like to try to understand those a little bit better. And I don't have the challenge below. Okay, so basically these are the 3 strings pages we went over. And essentially, I would say that this is all optional, but we have things for you to try in the Dictionaries chapter, just a few things in the About Dictionaries page. And then we have the things that I described in exception handling and the things I described about the strings. And so this is just basically the overview of the chapter. The students do quite a lot more, and you'll see that when you follow any of these links. So this is optional. It just depends on how you feel about the Whirlwind tour and whether you want to get some more hands-on with that. Okay, so that is it for your homework. I'm going to email that out. The link that you used today, use that link to get back to us on Wednesday. And then let's see, there was one more thing I wanted to mention.
And Andy is referring to the Zoom link. So when you register in Zoom, you got one link, and that's the same link for the 3 days.
Thank you, Ari. Yes, I might have been. Yeah, I did not say that clearly. All right, so yes, the link in your email with Zoom, use that on Wednesday as well. And I will email you both a summary of this homework, although it's in the slides as well. And I'll also email you a link to the YouTube recording of this session so that you can go back and hit pause on anything if you want to go through it a little bit more slowly and deliberately. And also for anybody who missed this particular workshop session. All right, so that's it. We're going to move to tech support. If anybody had any problems with their connection with their microbit, or just questions or off-topic conversations, ideas for improving the material, improving the presentation, etc. So we'll talk about that for a little bit and then close down after that. But we'll stop recording now, and thank you everyone for coming.